Dear S8 Mechanical Engineering students, welcome to online classes of Malabar College of Engineering and Technology. I am Jubin Jose here. So today we will be discussing some problems regarding the subject Design of Machine Elements 2 from the module 6. So already the questions are given to you. I will read once again the questions for you and let us move on to the solutions. So first we will be dealing with the problem 6.18. So in this problem, we have a seamless cylinder with a storage capacity of 0.03 meter cube is subjected to an internal pressure of 22 megapascal. See, we have a cylinder which is having a storage capacity of 0.03 meter cube and it is subjected to a pressure, a internal pressure of 22 Newton per mm square. The length of the cylinder is twice its internal diameter. See, the relation between the length and the diameter is the length is twice the internal diameter, 2 times the diameter. And the cylinder is made up of plain carbon steel 20C8 and ultimate stress is 390 Newton per mm square and the factor of safety is 3. Determine the dimensions of the cylinder. So what we need to find is the dimensions of the cylinder, that is basically the diameter, length and thickness. These are the dimensions of the cylinder. So in this question we have a cylinder with volume 0.03 meter cube, internal pressure 22 megapascal, that is basically 22 Newton per mm square, and the length of the cylinder is 2 times its internal diameter and its ultimate pressure is 390 Newton per mm square and the factor of safety is given in the question as 3. So what we need is we need to find the dimensions of this particular cylinder, that is diameter, length and thickness. So we know the volume of a cylinder is pi by 4 d square into L. So here we have denoted it as pi by 4 di square into L, where di is the internal diameter of the cylinder. And of course it is given in the question length is equal to 2 times the diameter. So instead of this length you substitute it as 2 into diameter. So what comes is pi by 4 into di square. Instead of this length you substitute 2 into di. So here what you will be getting is pi by 2. You are cancelling this pi by 4 with 2 and di square into di is di cube. So since the volume is already given in the question, the value of volume is already given in the question, so you can find this internal diameter from this equation. So internal diameter is cube root of 2 into volume divided by pi, which is 2 into 0.3 divided by pi. So what you will be getting is 0.267 meter. See, this value you are getting in meter. So this is basically equal to 267 millimeter. So we have found the internal diameter. Since the length is 2 times the internal diameter, we can find the value of length as 2 into di. That is 2 into 267, which is equal to 534 mm. So the length is 534 mm. Now let us move on to the step 2. Here we want to find the thickness of the cylinder. So we know sigma z equal to sigma out divided by factor of safety. So that is the circumferential stress is equal to the stress divided by the factor of safety. So that is 390, which is already given in the question. That is the ultimate sigma ultimate. This is the ultimate stress. So okay, you make it as sigma ultimate. So this is sigma ultimate divided, this is not sigma out, this is sigma ultimate divided by factor of safety. Since the sigma ultimate pressure is given in the question 390, so 390 divided by 3, which is equal to 130 Newton per mm square. Once you get the ultimate pressure or the circumferential pressure, we can find the thickness value of this particular cylinder using the equation T equal to Pi di divided by 2 into sigma z. So sigma c we have already found it as 130 Newton per mm square. So pi, it is given in the question 22, and diameter we have already found it as 267 mm divided by 2 into circumferential stress. So what you will be getting is thickness as 22.6 millimeter. See, this is our thickness value, 22.6 millimeter. So we have found all the basic dimensions of this particular cylinder. It's the internal diameter as 267 millimeter, length as 534 millimeter, and thickness as 22.6 millimeter. Okay. Hope all of you understood this particular question. Okay, students, now let us move on to the problem number 6.19. Okay, I will read out the problem for you. A seamless steel pipe of 1600 mm diameter contains liquid at a pressure of 4 Newton per mm square. We have a seamless steel pipe of 1600 mm and internal and a pressure of, and the pressure is 4 Newton per mm square, and we have the permissible stress as 200 megapascal, which is equal to 200 Newton per mm square. We need to find the minimum thickness. So as in the previous question, this thickness is related to the equation of this circumferential stress and all. We know that already. We have found in the studied that in our lower classes. Okay. So we know circumferential or hoop stress sigma c equal to pi di divided by 2t. So thickness T equal to pi di divided by 2 into sigma c. So we are lucky that we are provided with internal pressure, internal diameter, circumferential stress. So just what we need to do is just substitute the value of all these. So while substituting this, what you will be getting is thickness T equal to pi di divided by 2 into sigma c, which is equal to 4 into 1600 divided by 2 into 200, which is equal to 16 mm. So we'll be getting as thickness as 16 mm. So now let us discuss one more problem, that is 6.21. So refer to your question. I will read once again the question. A thin cylinder of 2 meter diameter is required to convey water under a head of 240 meter. Determine the thickness of cylinder if the allowable stress in the pipe material is 90 Newton per mm square. So we are provided with diameter, we are provided with head, we are provided with stress in the pipe, that is 90 Newton per millimeter square. So what we need to find is, we need to find the thickness of the cylinder. So now let us go back to our basic equation in your lower semesters. So we have studied there that the pressure due to a particular head of water can be calculated using the equation rho gh. So here the pressure is given as 240 meter, and we know let us to convey water. So we are using this particular application for conveying water. So we know the density of water as 1000, and we know the value of G, and H is already given in the question. So you can find the value of pressure, internal pressure Pi as 2.354 into 10 raised to 6 Newton per mm square. So this pressure Pi is 2.354 Newton per mm square. So this is in meter square and this is in mm square. Okay, so the circumferential stress is given as 90 Newton per mm square. So once you are provided with your circumferential stress, you can find the value of our thickness using this particular equation. Circumferential stress is equal to pi di divided by 2 into thickness. So substitute this stress value here, internal pressure here, and internal diameter here, and you can find the value of thickness using by solving this equation, and you will be getting as thickness T equal to 26.15 mm and approximately equal to 27 mm. Okay, so thank you all for listening. All of you, please write these questions into your notebook, and please contact me or if you have any doubts regarding this. Thank you very much.